Hello. Hello. Okay. Yeah. Okay, let's start again. Okay, do you guys have a setup? Anyone? Do you guys have the setup? Is it running like this? Where, yeah. Okay. So now we're gonna implement the chess rules, right? So go to pieces. We're gonna implement the rules for each piece. So the first piece we'll do is knight, right? Because knights are pretty simple. For knights, you can only move in 8 pieces around the knight piece, right? Where's the thing? No, it's not here. You can only move in the 8 pieces, so you just have to like code for the 8 pieces, the 8 positions around the knight. And before that, have we done inheritance? Piece, possible move, so. Okay. Okay, so we haven't implemented possible moves, so I'm gonna type in possible moves self and just pass for now. We'll code it later. And do that for all the pieces. Okay. And now we start with the knight, okay? For the knight, in possible moves, you want to specify the different directions that a knight piece can move, right? So a knight piece move 1 step forward and 1 step in either direction. So you can just hard code the moves that it's allowed to move in, right? -2, 1. Oh, I can just copy it. -2, 1. Maybe I'll copy it. Where's Okay. So these are the directions that a knight piece can move, right? One step forward and one step to the side in either direction, in all the four directions. Right. And then you'll say piece equals self.port.get piece at position. So this is the piece that it'll return the piece at that position. And I'm gonna say legal moves is just an empty list, right? And then I'll append all the possible legal moves for knight piece. And this is just a little card. If piece is none, I'm gonna raise an exception. Invalid piece, right? And then I'll say for every XY in moves, for every direction that I can move in, I'm gonna say destination is equal to, or I'm gonna get the coordinates of my destination plus Y plus X. Right. And if I can move in that direction, if my destination is valid, is in bounds, if it's within the board, and if the piece is not occupied by my own piece, and destination is not in self.port, not occupied by my own piece, right? If it's not occupied by my own piece and it is in the board, then I should be able to move there. So I'm gonna append the destination to legal moves. Right. And I'll do that for all the direction and then I'll return legal moves. Right. So this function is just gonna output a list of all the positions that the knight can move. Right. And that's it for knight. And now we're gonna think about the other pieces, right? So for rook, king, queen, and bishop, not the pawn yet. So the other four pieces for rook, king, queen, and bishop, they move either horizontally, vertically, or diagonally, right? And we can generalize all of that in the class piece. Instead of implementing all of that in each class, I'm gonna put them in the class piece, and then the other rook, king, and queen, bishop, they will inherit that property from piece, right? So I will have a function, I'll define a function called generic moves in piece. And I'll have self. For the arguments, I'll say, so we start with the position, right? Where the piece is. And if it's allowed to move orthogonally or diagonally, and the distance it can move, right, in total. So orthogonally just means vertically and horizontally, and diagonally means diagonally. And these two are Boolean values, so you pass in true or false. And I am going to define what orthogonal and diagonal are. So orthogonal is just one move in either direction, right? 1, 0, or minus 1, 0, 1, 0, then 0, minus 1, and 0, 1. And diagonal, same thing. Minus 1, minus 1, minus 1, 1, 1, minus 1, and 1, 1. Right? These are the 8 directions that you can move for all the other pieces. And same thing as before, I'll say legal moves is equal to an empty list, right? Now I'm gonna think about, so if I pass in true here, then the piece can move orthogonally, like a rook or the queen or the king, right? We'll have true here, and like the bishop, the king, and the queen will have true and diagonal, right? So I'm gonna say directions, well, an empty tuple. If I get true for both of those arguments, then the possible directions that I can move is just these two combined, right? If I can only move in the diagonal direction, then direction that I can move is just this one. And else direction is gonna be orthogonally, right? And now I'm gonna, so once I get the directions that a piece can move, all the possible directions that a piece can move, I am going to move it in that direction and check the distance that I can move, right? So I'll say for x, y in directions, if it hits a piece, it stops, right? I'm not allowed to hit my own piece or go out of the board. So I'll call that collision. If I collide with something, then it'll stop in that direction. Otherwise, it'll continue to move and check if I can move in that direction, right? So I'll start with collision equals false. And for each step in range of 1 to distance plus 1. So here I'm just saying for all, if I can move up to 8 steps, I'll try to move up to 8 steps, right? So pieces like the queen and the king and stuff like that, they can move up to, or the queen and the rook and bishop can move up to 8 steps. So I'll try to move it by 8 steps. If I can't, then that's fine. So I'll say if I collide, then I'll break. I'll go out of this loop, right? I don't need to check for the rest, because if I collide, then I can't jump over it, right? Now I will check for destination. I'll try to move this piece coordinates position dot row plus step times y and position dot column plus step times x, right? Yeah. So I'll try to get, I'll get the destination, the coordinates of the destination that this piece is trying to move, that this piece could move. And if the destination is not being occupied by any of the pieces, then I can move there, right? If it's a blank piece, then blank space, then I can move there. If it's not occupied by white, plus self.board.occupied by black. So if the destination is not occupied by any pieces, then I'll say I'll append it to legal moves. Or if the destination is not in bounds, which means it's outside the board, then it can't move there. So it will stop, right? It's not in bound, or destination in or self.board.occupied self.color, which just means if the position that I'm trying to move is outside the board, or the position that I'm trying to move is already occupied by my own color, by a piece of my own color, then I'll say collision equals true, right? It can't move there anymore and any place further than that. Otherwise, I'll say legal moves dot append destination and collision equals true. Because this else statement is just saying the place that I'm trying to move is not in here, which means it is occupied. Oh, yeah, it's not occupied and it is inbound, but it's not my own color, meaning the place that I'm trying to move is in bounds, but it is occupied by a black piece. So if it's occupied by a black piece, I should be able to move there, but I can't move further than that. I can't jump over a black piece either. And then at the end, I'll just return legal moves. Okay. So that's the implementation for generic moves. And now you implement this function for all the pieces, well, the 4 pieces in possible moves. We'll say define possible moves. It's going to return from its parent class. It's going to call this method position. A rook can move orthogonally, so this is going to be true. This is going to be false because it can move diagonally. And it can move up to board size. And if I don't have board size defined, I'll just say 8. It can move up to 8 pieces. Right? And then I'll do this for all the other pieces. Define return position. Because it's a bishop, it's going to be false here and true here. Queen is going to have true here. The king is going to have true. Oh, this is already true. True in all directions, but it can only move in one space. Right? Yeah, seems right. Okay. Now we've implemented the movement for all the pieces except the pawn. So we'll work on the pawn now. Size. Here's the pawn. So for the pawn, I'm gonna pass in position like the other ones. And okay, so the pawn, if it's white, then it can move up in the positive direction. But if it's black, then it'll move in the negative direction, right? So we'll just hard code that. We'll hard code if self.color is white, then I'll just say this is where it is starting at. Home row is at 1. Direction it can move up, and its enemy will be black. Otherwise, its color will be black. So its home row is at 6, because that's where it starts. And it can move down, right, in the -1 direction. And its enemy will be white. And like the other ones, I'll just say legal moves is an empty list, and then we'll just append to it depending on how. Okay. So I'll make a list called blocked, where it stores all the positions of occupied places, right? Because if it's occupied by any other piece, whether it's my piece or your piece, then it will be blocked, right? Dot occupied black, and forward would be board coordinates. I forgot an S. Yep. The board coordinate. Yeah. Position dot row moved in that direction, and position dot column, which is out moved. Right? You don't move sideways for a pawn. So if the move forward is in bounds, if it's within the board, and the move forward is not blocked, not in blocked, then I can say I'll move there, right? It's a possible place to move. Legal move dot append forward. If the pawn is at its home row, then it has the chance to make a double move, right? It can move 2 steps instead of 1. So if the position of the pawn is at its home row, it hasn't moved at all, then double forward would be board coordinates forward dot row plus direction, just doing it 2 times, forward dot column. So here you moved it 1 time, here you moved it another time. So now it's moved twice. And now we check if it could move there. If double forward dot is in bounds, and double forward is not being blocked by any pieces, then I will append that as well. Legal moves dot append double forward, right? And for moving, that's it. Now we'll try to implement the attacking. So for the attacking, the pawn can attack sideways, like one place to the side, or one place forward and to the right or to the left. So I'm gonna say for A in range. What is a typo? Thank you. For A in range of -1 to 2 with 2 steps. This is just a fancy way of saying look to the left and look to the right, right? Attack is equal to board coordinates of position row plus direction and forward dot column. Not forward, position dot column. Plus A. So it'll move 1 direction, or it will move 1 step in the direction that it's supposed to move, and check and move either to the left or the right, because A will have the value of -1 or +1. So it'll move either to the left or the right for its attack. And if the attack is in bounds, is in bounds and attack itself dot board dot occupy of enemy. Then I'll say legal moves dot append attack. Right? If there's an enemy piece there, then I'll append attack to legal moves. And then I'll just return legal moves. Right? Okay. And now we will implement board dot occupy. We haven't imported board coordinates, so I think I'll do that. Right. So let me import board coordinates from dot utils import board coordinates, and this should be fixed. Right, yeah. Okay. So now we've already defined this one. Oh, okay. So we haven't defined the occupied function method here in board. So we'll do that now. So go to board. We don't have dot occupied, which is fine. So I'll do it here. Define occupied self with color, right? Because we want to take a color as an argument and check if there are pieces occupied of that color in that place. So this function is going to return a list of coordinates occupied by that color, black or white. So as usual, I'll have an empty list and I'll say if color. What's happening? What's that? Oh, did you finish? Oh, no. It just it can be a bit sensitive. It's working. Everything here working. Okay. If the color is not in black or white, this is just a little card, and I'll say invalid color. Right? This is just a card to make sure the code doesn't spill over. Now I check for each coordinates in the state of the game. Say if the state self.state of the color of the coordinates and the color at that coordinate is equal to the color that I'm passing, then result.append that coordinate, right? Yeah. Yeah. So it's just saying I want a list of all the coordinates of the black piece a black piece is at. Then this will go to the board and check its state, take the coordinates and check for every coordinates if it's black. If it's black, then I'll append it to result. Right. Then I'll return the list of the map of letter to board coordinates with the result. And now I haven't imported this one, so let's go import that in utils, right? Yeah, it's in utils. board coordinates and letter to board coordinates. Okay. Okay. So now we've set the rules for the pieces. Now we're gonna enforce the rules, right? In board move, we will only allow it to move if the move coordinate is in legal moves for each piece. Okay, that makes sense. So here we have move piece as destination, get piece at P1, destination piece is at P2. So this function is moving the piece from P1 to P2. Okay. Okay. So to verify, I'll say enemy is equal to self.get opponent so that I know who my enemy is. Moved underscore piece dot color. If I'm black, this will give me white. If I'm white, this will give me black. Okay. And possible moves is going to be a list of move piece dot possible moves of P1. Right? From my original position, what are the possible moves? I'll store it here. Right. And if I'm trying to go to my destination, it should be in possible moves. So if P2 is not in possible moves, then I shouldn't be able to move there, and I'll raise an error. Invalid move. Right? If it's allowed to move, then it goes on. Otherwise, it won't. It'll raise an error. Okay, and now we can try running it. See if it works. Okay, can I move here? Yes. Nice. This isn't good. I have to save it. Position is not defined. This position. Huh? Possible moves takes in position here. And invalid piece is not defined, so I'll define it. Import. Where is it? Oh, it's here. It's here, right? Yeah. Invalid move. Why is it grayed out? Oh. Okay. Piece. Position is not defined again. Where is this? Well, it has position here. It has position. This doesn't have position. Position. I can't type. Oh, possible moves. That's it. Okay. Now I should be able to run it. Control S. Wait, cannot import name.
Just create the embedded piece.
Not just say exception. Okay. Now I can't move here. I can't move here. I can't move here. This is not happening. One object has no attribute board.
Okay. Here. No, not board, it goes board.
So the board equals board.
Yep.
Then the board has been defined.
Yep. And then just run it.
How it moves.
Is it supposed to be embedded?
No.
Oh my god. Yeah, let's see.
P2 is not impossible moves.
So possible moves might be wrong.
I go to pieces. I was trying to move a pawn. Wait, let me try to move the other pieces.
Yeah.
No, so this is
Try to print out possible moves.
This is working.
Right, let's see.
Not printing.
Sure.
B5 to C5.
Sure.
I'm gonna check the completed version. Piece P1, move piece P2.
East possible moves.
Debugging.
Yeah, debugging, fun.
Oh, there's no possible. Nothing's impossible. Is that why?
No, it shouldn't matter though.
Oh yeah, because we have it here.
Oh my god, your scrolling is so
Very bad. Okay. I think P2 is not impossible moves.
Move D4. Is that correct? A, B, C, D, 4, 4. Move D4. Okay, this is correct. But where is it? Move. Mr.
P1. Just
This one. Oh wait, no. This one. C3, D3. Why are you 3?
it's not C3. Should be B3 to D3. Oh no, no, that makes sense. D3.
This is B3 to D3. Oh, you didn't do the equals.
What?
Equals. Go to utils. Need to do this.
Okay.
Yeah. Okay. Go. Maybe explain that as well. That's for to check if two classes are equal.
Okay.
Yeah, amazing. Probably need to explain that.
Okay. So the problem was we forgot to define this one. In utils, it checks if the two classes are equal. So I'm gonna return self.row equal other.row and self.other or self.column equal other column. So it's just returning true or false, right? And control save. This should work. Okay, that works. I can't move. I can't move. I can't move. I can't move. This can. Oh. The pawns can move.
Yeah.
This is fun. Takes one position of argument over given two. Position.
What's the error? Yeah, go there.
There's nothing there.
Board.py.
Oh. P1. That's making sense.
And P1. We'll close your existing. Okay. Oh. Right. Scroll up and to see like what's printed.
Oh my God.
The scrolling is cool. Oh, what?
We printed P1. So
No shot, that's P1, right?
This is a P1.
Go to like, say like, yeah, P7. Right, there, bring P1 here, right? Oh wait, no, it's back. Oh. Okay.
A3 to C5. No. So also can be one.
Plus the arrows over there.
P1 is A3. Is that right?
P1 is A3, yep.
Oh, that's right.
But two are given. Where? How are you giving two? Oh. Yeah. Okay, no control click.
No, you can right click it.
Okay, no.
You can go to definition. Oh. Oh, is that a Y?
Nope. Let's try this.
I don't think that will work.
Yeah, I don't think it will be much different, but you know, we can try. Oh, we can try this first. Okay, okay.
The knight moves. Because we
So
implemented knight. So it should be like maybe the problem is with the
it
generic.
may be the
rule.
generic moves. Pick one position.
Let me go to generic moves. Yeah, if I got it right. -100.
Bishop. You see the problem?
Ah. Okay.
Like this, I think. Yeah, just it's the same for
Just the
everything.
bishop.
No,
Oh.
it's the queen also.
It's for everything.
Yeah. What happened?
Good.
Ran into an indent. Yep. Yep.
All right.
Okay, try running it again.
Fixed.
Fixed. Let's hope.
I move
Like
this. I move
Like
this.
this.
I move this. Super object has no attribute generic move.
What? Did you use super bracket?
I think I did. Yeah.
Is it like the sample code? Go to computer. Cool. Go to GitHub.
Where is this? This is pieces.
Did you typo?
Where's the typo? Moves.
Generic.
Moves. Right?
Yeah, I think so.
Yeah.
Yeah.
I love coding.
We all do. I mean, you can just replace move with moves, right? Or like replace this thing. Yeah. Typo.
I love typos.
You need to restart the thing. Right.
This one.
This one. Non-type has no attribute upper.
This is not non-type.
Okay. That's
The knight moves.
yeah, so it's still generic move.
Okay.
Still a problem with generic moves.
It's generic moves.
It's in pieces. Let's go see where's the error. No, not this. It's like non-type.
The non-type error. Why is that?
Where's the error?
We run it again. This moves here, this moves here, this moves here.
Okay, let's see. Oh, yep. Just remove my print statement. It's my print. No, it's my print.
Oh,
Yeah.
I don't know if this one is right.
Yep. Wait. Try again.
How's that here?
You are
We're doing so well.
close your Python and restart it.
Oh,
Yeah.
let's try this one.
Yeah.
Yes. Let's try this one again. Okay. Queen moves. The king moves.
Yeah.
This king moves.
Knight,
Bishop moves.
bishop.
Oh, the knight moves.
Yeah.
Okay,
Works.
everything's working. So they
You want to
would
summarize what fixes you made?
yeah. So I don't even remember anymore. So there were things going on with generic moves. Namely just a typo. And some print statements that we didn't remove. So those were the errors. Don't you love coding? So now where was I? I haven't. No, I haven't. Yeah, I'm a check. So now I'm gonna check for checks. How interesting. I'll go to board, in the move method. Yeah, in the move method, I'm gonna say if the piece that I'm trying to move is not in possible moves, or if it is in possible moves, and I'll have a function called is in check after move. Do I have that? No, I don't. So I'll type that in. Okay, so it starts like this. Underscore all possible moves of enemy and self dot is in check after move of P1 and P2, P1 to P2. Then there's a check, right? Because of this. And I haven't defined these ones, so I'll define them now. And I can type race. And now another if not in possible moves, or if possible moves is empty, and self dot is in check, which means the opponent checked you, then piece dot color. What's this dot? Raise checkmate. Oh no. Okay. So if there's a checkmate, there will be no possible moves. So though if there is no possible moves and your piece is in check, then it's a checkmate. If there are possible moves and you're in check, then it's just a check, right? Elif not possible moves, then I will raise draw. Right. So if there are no possible moves, but my king is not in check, then it's a draw. Right. So these functions haven't been implemented. As far as I know, yeah, they haven't been implemented. So we'll implement that right now. I'll go down here. Do it here. First, I'll do the all possible moves function. And it takes the color as an argument. And it's going to return the list of that color's possible moves, right? And doesn't really check for the moves. It just checks. It just gives you a list of all the possible moves of the color. So this is another guard. If the color is not in black and white, then there's an error. So I'll raise invalid color. And I'll start with a blank list and check for each coordinates in the list of self.state.keys. So this is a dictionary. I'm changing it to a list. If self.state of coordinates is not none, which means that there is a value, and self.state of coordinates dot color is equal to the color, then I can move there, right? Moves equal self.state of coordinates typo dot possible moves the coordinate, right? Because this is taking the coordinates, I'm just transferring it to letters. So this is moves. If I have values in the move, if I can move, then I'm gonna append it. I'm gonna add it to the result. Right. Otherwise, at the end, just return the result. I just want to know how many possible moves there are. Okay. Now the next one is in check. Is in check. Same as before. The only argument it takes is the color. So here I'll say self dot verify color of color. What's this do? There's no definition. Okay. So we'll do that later. And now we're gonna take the king's location. Self dot get king position of color, that color. And opponent is the other color. Then I'm gonna return king location in self dot all possible, oh, it's an underscore, all possible moves of opponent. Right? If the king is in this position, then it'll return true, then it is in check. If the king is not in the position, if the king is not in the possible position of the opponent, then it is not in check. That's it. Another function, get king position, because we haven't defined that function. Get king position, same as before, we just take the color. And for each position in the state of the game, is king at that position if it is the king. So I'm going through all the coordinates where you have a piece. And if that piece in that position is a king, and if that king is of my color, then I'm gonna return the position of that king. Right. And now the final thing is in check after move. So because it is after move, I'll have two coordinates moving from P1 to P2. Temp is equal to deep copy. I don't think I have deep copy imported. Yeah. So import deep copy from the library copy. Deep copy just makes a copy of the object that is independent from the object that it's being copied from. So changing temp will not change whatever copy that you made here. So it's making a deep copy of itself. And I'm gonna do a move and check if I'm in check or not, right? Return temp dot is in check, self dot get piece at p1 dot color. Right here, I'm just making a copy of myself, and I'm doing a move from p1 to p2. If I'm at p2 and I'm in check, then I'm gonna return yes, it is in check. Or if it's not in check, then it's not in check. Okay. Hopefully I can run this. Does it run? Nope. Self.verify color. Board object has no attribute verify color. Okay. So I'm going to implement verify color. Define verify color. Oh, there's an underscore. So with the color. So this is just a guard. If the color of my piece is not black or white, then I'm going to raise an error, the invalid color error. Okay. Board object has no attribute verify color. Wait, where is this? Self dot underscore verify color. Has no attribute is king. You don't have is king. Okay. Okay, so we haven't implemented some functions. Namely is king, self, comma, place. If it's a king, it'll just return is instance of piece of the king. All right. And I'll do this for the other pieces. This king piece on this rook piece rook. I haven't imported. Generate piece on king. I don't use piece here. That's what it's about this. Piece is not defined. Nice. What?
Open the that's right. You see the typo.
PIECE.
One line ago.
There's a typo?
Yeah, it's piece. Self on
Oh. Wait. Place. I did place. I did even worse. It's piece. Okay. Hopefully. Oh, yeah. The stir object has no attribute role.
in the board where you call something not possible.
All possible. This one, right? The color is not in black and white, race and font color without 0.
Return king location. Is king location string?
Where?
Is this returning a string?
This is returning a string.
King location.
This is returning a
Calm
string.
down. Okay, don't panic. Okay. Is this returning this? Go there. Control click. Or like just go there. Like this one. So this king. Yeah, see, this is returning a string. So like, go find it. How this does. Yeah. Go there. And then check this is simple.
Yeah. Position.
There you go.
Position. What's happening? Color string.
Line here.
Return letter to port coordinates. Oh, I'm returning pause.
Yeah.
Okay. Return.
Yeah.
To port coordinates of pause.
Yes. Good.
So the one here is wrong?
Yeah, probably.
Okay.
Let's see. Run again. Nice.
Yes. Good job.
Good job. Okay, then move everything else.
Move.
Yep.
Can move. Can't move.
Yep.
Can't move.
Okay, and then tell them what previous you did.
Okay, so in board, so the error was in board get king position. I did return pause instead of return letter to board controls of pause, because this is supposed to return a string, right?
And return a board coordinate.
Oh, yeah, the
Yeah.
board coordinates. Okay. And that's it, right?
I think so.
Yeah, that's the end.
Yeah.
So that's it. You can run chess and play chess-ish now.
Yeah.
I guess. Yay. We've
Okay.
made it.
Good job. Whoa.
Good job, guys.
Okay. Okay. Thank you everyone for staying till the end. As you might notice, we still have a bunch of like various chess rules and features we haven't implemented,
Yeah,
like
like en passant.
castling, en passant, bunch of other like things to do, like tying. I think we don't even have draw. I'm not sure, but yeah. So but the goal of this workshop is hopefully you like learn something about like just how to think of software design and how to like how to convert like a problem into a software solution and solve it in a code. And we have a bunch of bugs, as you might notice. But honestly, what software engineering without bugs, am I right? So yeah, I mean, I guess you could also kind of get to see us like figuring out how debugging stuff, putting a bunch of print statements everywhere. That's honestly what like most debugging or like problem solving bug fixing is. It's like putting a bunch of print statements and see what's going wrong. But yeah, so this is the end of our workshop. Thank you all of you that stayed to the end. Really appreciate it. Hope you guys learned something out of it. Really hope. Yes. Yeah. So yeah, in like 2 weeks time, we're gonna have like a beginner-ish hackathon that is partially organized by this dude, where you get to like implement, like use your skills and like whatever you learned here and apply them to solve like another software problem. The theme for that hackathon or like the project you'll be working on is like a bot that plays Battleship, the game. Yes, plays Battleship, the game. And then so like your submission will be put against other participant submission, and I want head-to-head fight. Sounds pretty sick to me, honestly. But yeah, so if you guys want to join, go sign up. Where you been?
If you remember, you can email if you're not on Facebook, like
There. You can sign up eventually. Sometime soon. Before you leave, can I open this card for the QR code?
stop the recording.
Okay, stop recording.
Okay,
Yeah. Okay, before you leave, I would appreciate it very much if you can give us some feedback. This form, please. Thank you very much. It'll help us improve our workshops in the future, next year. Yeah, I plan to do like these kind of workshop every year, around like this time semester 2. So yeah, much appreciated. And how do I stop recording?
Just stop sharing. I think the recording's here. No, yeah.